Hello, in this video, I will explain about separable differential equation and I will give you for example here. So the easiest way to do separable differential equation is by using the Leibniz notation here. So if you have a differential equation like this, y prime is equal to sine 5x, you change it into dy over dx notation, right? And maybe let's do all the example here to get the step-by-step done. Okay, let's do the first one here. We have a differential equation, dy over dx is equal to sine of 5x. And the first step that we need to do is to, what is it? Gather all the same variables, on one side. So we will have the y variables on one side and x variable on the other side. So we treat this dy over dx as a fraction. So we can move this dx to the right hand side. So we will have dy, and that will equal to sine 5x dx. Okay, and if we already separate this variable, so this all the y is on the left hand side and all the x is on the right hand side, we can just integrate both sides. So we can have to integrate both sides. So we can just use integral dy on the left hand side and then integral sine of 5x dx. And I think that will be good. So the integral of dy is y plus some constant, but I will move the constant later to the right hand side. So I just write y on the left hand side. And then on the right hand side, the integral of cosine is minus cosine, but we have to use chain rule. So I will have minus 1 over 5 cosine 5x here. And remember, we have to add a constant here. Let's just rename the constant there as C1 here. And that is all. So this is the answer for question number 1. This is the solution of dy over dx is equal to sine 5x. Okay, let's move on to the second example here. So we have this one again, dy over dx is equal to x plus 1 squared. Okay, so here let's separate all the variables, right? Separate all variables so that all will be on one side. So how to do that? Let's see here. Again, our dy is only from our y is only from dy here. So we have dy here, and that will equal to x plus 1 here squared, right? And then multiplied by dx because we move this dx to the right hand side. And so we can integrate both sides. So the second step will be integrate both sides. So here on the left hand side, I will have integral of dy. And on the right hand side, I will have integral of x plus 1 squared dx. Okay. Integral of dy is just y plus some constant, but I will move the constant later to the right hand side. So I just write it as y. And here I think I will just use this property here. So I will have x squared plus 2x and then plus 1 multiplied by dx. Good, so I will have our y here. That will be 1/3 x to the third power here by using the power rule. And then this one will be x squared and this one will be dx. And do not forget to add the constant. So I will add the C1 here. And this is the solution of this differential equation. And we have done for the example 2. Good. And now let's move on again to the example 3. It is more complicated, but it is doable. So the first step will be separate, right? Separate all the variables. So how to do that? And I think we will move this to the right hand side. So we'll have dx is equal to minus e to the 3x here dy. But then we can move this minus e to the 3x to the left hand side, right? So I will have minus dx divided by e to the 3x. And all of that will equal to dy. Okay, let's rearrange things so that we can have a nicer look. So I will have dy here, and I will have minus 1 over e to the 3x. I can rewrite that as e to the minus 3x. And then dx. Okay, we have separated all the variables, and now we can integrate both sides. So the only thing that we need to do is separate and then integrate. Separate and then integrate. So we will have integral here, dy, and then that equal to, I think I will just put the minus sign outside. So we'll have integral here, e to the minus 3x dx. Good. Integral dy is just y. And then we will have minus here. And then we will have this one here using chain rule. Remember, we have to use chain rule. So I'll have minus 1 over 3 here. And then this still be e to the minus 3x. Then plus some constant. Or we can rewrite this as y is equal to 1/3 e to the minus 3x. Or let's just name constant here as C1. So I have plus C1 here. And I think that's all for this example number 3. This is the solution of the separable differential equation. Okay, now let's move on to the last example, which is example number 4. So the first step that we need to do is to separate, right? Okay, let's see that. Let's isolate this dy to the left hand side. So I will have dy here, and that will equal to, I think we will have y minus 1 squared and then dx. Good. And now what can we do from here? I will have dy and then over y minus 1 squared here. And that will equal to dx. And we have a nice separation here. So we can just integrate both sides. So we will need to integrate. Right? Okay, how to do that? Let's do exactly like this. So we will have y minus 1. And then that will be on the minus 2 power. So we'll have dy here. And here we will have integral of dx. Okay, now what can we do here? I think I will use substitution here. So u is equal to y minus 1. So we will have this integral here. So we will have du is equal to dy, right? So this integral here change to integral u to the minus 2 and then du, right? Because dy and du is the same. And then that will be, this one will be x plus some constant here, c1. Good. Now this can be solved using, yeah, I think the power rule here. So we will have minus u and then to the minus 1 here. And that will be x plus C1. But then I will have minus 1 over u, but u is y minus 1. Y minus 1, and that will equal to x plus C1. Okay, but I think I will need to make it y is equal to something, right? So let's move things around. So we will have y minus 1 here. Y minus 1 is equal to minus 1 over x plus some constant, right? And then we will have y is equal to 1 minus 1 over x plus some constant. And I think that is the final result that I can get from here. So that is all for the problem here for separable differential equation. Hopefully I did not make any mistakes in my calculation. Thank you for watching. See you in the next video. Bye bye.